Picture the universe with a set of rules. Don't think too far. Let's say objects repel and attract each other. Let's assume that it happens to some degree, and this degree is caused by some factor. Congratulations. You've obtained a set of rules to describe this model. This might not be our universe, right? Or is it? To describe this universe, we imply rules to acquire more rules. To do this accurately, without making any more assumptions to obtain more rules, we use mathematics. That's right, you put shit in, you get shit. This all started when Galileo decided to describe the world mathematically, because the Greeks at the time were full of shit. From the smallest atom to the largest galaxy, mathematics is the language that describes it all. It's the code that underpins the laws of physics, dictating how things move, basically everything. It's also the reason why you hate your math teacher. But think of it like this. Imagine flat furniture trying to assemble flat furniture without the instruction manual. Chaos, right? That's what it would be like trying to understand the universe without math. By the way, no offense for calling you flat furniture. Maths provides the framework, the equations, the tools to decipher the universe's intricate workings. It's how we make sense of the world around us, from the predictable motion of the planets to the bizarre behavior of subatomic particles. Basically everything indeed. Let's rewind a bit. Back to the time of Isaac Newton, a right genius with a penchant for gravity, literally. Newton realized that to describe the motion of falling apples and orbiting planets, he needed a new kind of math. Enter calculus, a branch of mathematics that deals with change and motion. Or to be more precise, it compares change between two objects, of one being an entity of the other. With calculus, Newton could finally explain why that apple fell down instead of sideways, much to the relief of unsuspecting passers-by. It's also Newton's fault for you having F on your calculus test. This was a pivotal moment in scientific history, and I am not talking about your F. I am talking about calculus becoming the bedrock of classical physics, allowing us to understand everything from the trajectory of cannonballs to the rhythm of the tides. Section 4, Einstein's Wacky World, where gravity bends everything. Fast forward a few centuries and along came Albert Einstein, a man who saw the world as bend. Not just his head was retarded, but space and time themselves were. Einstein's theory of relativity, which revolutionized our understanding of gravity, was built upon a foundation of complex mathematics, which I like to call complex calculus. Thanks again, Newton. Imagine space and time as a trampoline. Massive objects like stars and planets create a dip in this trampoline, a curvature in space-time. This curvature is what we perceive as gravity. Mind-boggling, right? Einstein's theories, though mind-bending, were firmly rooted in mathematics. His equations predicted phenomena like black holes and gravitational waves, phenomena that we are only now beginning to observe directly. Section 5, Quantum Quirkiness Maths, explains the truly bizarre. Now, let's dive into the realm of the very, very small, the quantum world. Here things get really weird, even weirder than your toxic ex-girlfriend. In the quantum world, particles don't behave like tiny billiard balls. That's the lie they taught us young students. They're more like fuzzy clouds of probability existing in multiple states at once. It's enough to make your head spin. But fear not, for mathematics is here to guide us through this quantum jungle, only if you know it. Do you? Quantum mechanics, the branch of physics that describes this wacky world, is heavily reliant on abstract mathematical concepts. Section 6. The thrill of the unknown, maths and physics, a never-ending adventure. The beauty of the relationship between maths and physics is that it's a never-ending story. Every new discovery, every breakthrough raises more questions than it answers, pushing the boundaries of both disciplines. Who knows what mysteries the universe still holds? Dark matter, dark energy, the possibility of parallel universes. These are just a few of the enigmas that keep physicists and mathematicians up at night. But one thing's for sure. The journey to unravel these cosmic puzzles will be paved with mathematical equations and fueled by the insatiable human thirst for knowledge. So, cheers to that. Now, where's that pint?